Okay, with this question right here, we are looking at the amount of money that we need to have in an account when we want to retire. And let's say that you're wanting $1.3 million, so that's $1,300,000 in your account at the age of 65. Okay, you currently have invested $12,000 at age 23. Okay, and again, we want the 1.3 million at the age 65. So this one asks us what rate of return we want on our investment, or that we need to have on our investment, I should say, in order to obtain our $1.3 million in our account at age 65. And the interest is compounded continuously. Well, if interest is compounded continuously, then we're going to use our compound interest formula for compounded continuously, and that's this one here. Okay, and this is the amount of money we will have, the ending amount, if you will. P represents our initial investment. The number E, all raised to the rate times the time. Okay, and what we're going to do right here is we're going to fill in what we know. We don't know what our rate is going to be, okay, but we know what our ending amount is going to be. That's going to be 1.3 million. Okay, so I'm going to fill that in. I've got 1.3 million on this side. And then the principal amount, we know that as well. That's our $12,000 that we have currently invested, times the number E, all raised to the rate. We don't know the rate, so that's just R right now. 42. I got this 42 from 65 minus 23. That's going to be 42 years. So 65 minus 23 is our time, if you will. That's our 42. Now that I've got this set up, now I can start solving this one. We're going to solve it for R. So the first thing I'm going to do is divide both sides by 12,000. I'm trying to isolate this R, and so this will be our first step. So I divide both sides by 12,000, and 1.3 million divided by 12,000 is 108.333. And notice how I'm not really rounding right now. I know this one at the end we're going to need to round it, but right now I'm not going to round it. I think that you should wait to do that until the very, very end. So now I've got this. This is E, all raised to the R times 42. Now what I'm going to do, we know that E, in order to get rid of our E, I'm going to take the natural log of both sides. So the ln of both sides. So I do that now. This is the ln, whatever this was. Remember, with our rules of equations, if we do it to both sides, then we have not changed its value. This one here is equivalent to this one here. We haven't changed any of the other values. The reason why we took the natural log is because we know that the base on a natural log is E. And so if we do this, I can get rid of my number E right here. The ln and E cancel each other out. Okay, that will basically just leave us with this. ln 1, see, I didn't change anything on the left-hand side at all. This ln and this E basically crossed each other out, and I'm left with whatever my exponent was here, and this is R42. I just wrote it in proper form. We typically will see that that is a coefficient, so we'll put the 42 in front. But this is R times 42, and this is still the same thing here. Okay, but it's a little bit easier to understand here if we put it in the correct order. Now that I've got that, I'm looking for what R is, and I don't know what that is yet. So the next thing we're going to need to do here is plug this left side into the calculator. We've got to figure out what the natural log of 108.333 is. And it sounds fairly complex, but it's really not too bad. We've got our calculator, and our calculator has our natural log button. So I'm going to use that. I'm going to go natural log, and then I just type it in here, 108.333. Remember to use your close parentheses. So I do that here. I've got 4.68520, and again, I tried my best not to round as much as I try to avoid rounding until the very, very end. So I'm going to plug that in here, 4.6852 equals 42R. Okay, now we're trying to find out what R is, so I have one last step. I need to divide both sides by 42. I do that now. Okay, whenever I use my calculator, I'll just take that number, whatever that number is, and if I just hit divided by 42, I did not round this number at all. I just kept that number, whatever's in there. And I just say divide it by 42. Notice how it says answer. That was my previous answer divided by 42, which is really what I'm looking for. Then I just hit enter here, and it gives me this number, 0.11155, and it keeps going down the line. So I'll just simplify that here, 0.1116, and I just rounded that little piece there. And that's okay now because this is my answer. Now it asks me to round the answer to the nearest percent, so I need to round this one. To the nearest percent, with the percent, remember it's a decimal, I move it over 2 spaces. So instead of having it in front, I just move it over 2. This will be 11.16%, but it asks me to round it to the nearest percent, so that's the nearest whole percent, which would be 11% in this case. So I need to have an 11% return in order for this $12,000 to grow into $1.3 million. And this will actually occur, and that's 11% is roughly what the market has been doing for stocks and everything. So if you had $12,000 and you invested at age 23 in the stock market 43 years ago, and you looked at your account balance now, it would be roughly 1.3 million. And so this is the importance of trying to save money now, so that whenever you're older, when you want to retire, you will actually have enough money to live off of.